Hello everyone, welcome to Math 153, Statistical Reasoning. So here's the situation. We have multiple choice questions, and each question has 5 answers, A, B, C, D, or E. And one of these answers is right, and the other 4 are wrong. Oh no, I should have studied. I didn't study, so I have to guess. I'm going to guess A, right? That's my guess. When I used to teach in the junior high, the kids had a method called abacaba, and it spells out abacaba, A-B-A-C-A-B-A. And if they had to take a multiple choice test, and if they hadn't studied, they would just write abacaba, and that was their method. And I always remember that as being what? As being quaint somehow, but oh so wrong. So it's not a total disaster, right? Because I've studied most of the test. There's just 3 things I don't know. I thought it was in my mind, and then when I saw the questions, I had no idea. And so on 3 of the questions, I have to guess. Well, one possibility, and this is this strange notation, it's a new notation they introduced, is that the first question I guess, I get wrong. W stands for wrong. And then the second question I guess, I get it correct. That's the C. And the third question I guess, and that's another C. I got it correct. So I got 2 right out of 3. I am really, really lucky today. And what's the likelihood that I would get the first guessed question wrong and then the second and third guessed questions correct? And you think to yourself, well, wrong and correct, and I say, yeah, you're on the right track. And you say, oh, okay, then I know this. And probability means to multiply. Oh, yeah, and they even told me, use the multiplication rule to find the probability that you get a wrong answer and then a correct answer and then a correct answer. Well, what's the probability of getting a wrong answer? So this is a theoretical probability. I haven't done anything yet, so I have to use the theoretical probability model. And that says it's a fraction. And in the numerator of the fraction is how many ways can you get it wrong? And I say, well, 1 answer is right and 4 are wrong. So 4 is in my numerator. And how many ways can you write an answer? Well, I can choose A, B, C, D, E. I can choose 5 answers. So 5 is in my denominator. So the probability of a wrong answer is 4/5. And similarly, there's only 1 way to get a correct answer. So 1/5. And 1 way to get a correct answer, so 1/5, 4/5 times 1/5 times 1/5. They want an exact answer, and so in order to be exact, I'm going to use a fraction, right? So on the top, I have 4 times 1 times 1. I'm thinking that's about 4. And in the denominators, I have 5 ways, 5 ways, 5 ways. 5 times 5 times 5 is 125, and they like me so far. Well, suppose instead of getting the first one wrong and the second 2 correct, suppose I got the first 2 correct and the third one wrong. Well, then it's 1/5 times 1/5 times 4/5. Wait, this is the same thing. It's just in a different order, isn't it? Yeah, exactly right. You're thinking. So 4 over 125, and then what's the probability that you get the first correct and the middle one wrong and the third one correct? It's the same thing again for the same reason. And it still seems to like me. So what is the probability that I get exactly 2 answers correct? So I'm guessing 3 questions. What's the probability that I get exactly 2 correct? Not 1 correct, not 3 correct, not none correct, but exactly 2. And you think, well, it could be the second and third are correct, or it could be the first and second are correct, or it could be the first and the third are correct. So there are 3 different ways that I could get exactly 2 right. So it could be this, or this, or this. And you're thinking, or, I know or. I sound like a seal, don't I? Or. I know or is the addition rule. Wait, make sure there's no overlap. No, there's no overlap. These are 3 different sequences of answers. So the addition rule allows me, if there's no overlap, to add the 3 probabilities. So on top, 4 plus 4 plus 4. I'm thinking that's 12. And on the bottom, it's a common denominator. So this is an easy problem. It's 125. Cool. So what's the likelihood? I said before, you're really lucky if you get 2 right. What is the probability that you get exactly 2 right? And you look at this and you say, this is like 12 over, it's like 1 over 10, right? The bottom is about 10 times the top. And so you have about a 10% chance, actually a little bit less, of getting 2 of those questions right. And you could do something similar and you say, well, what's the probability that I get all 3 of them wrong? And you say, well, there's 4 ways to get them wrong, times 4 ways to get them wrong, times 4 ways to get them wrong. 4 times 4 times 4 is 64 125ths, right? So 64 125ths. 64 is about half. It's a little more. So you have about half probability that if you guess 3 answers, you'll get all 3 wrong. What's the probability you get only 1 right? And you could lay them out like this. And what's the probability you get all 3 correct? And you could do that and find all the different possibilities.